Hi everyone, this is Transformation, and then I'm going to finish the quiz for this unit. Now, once again, back to this question. I saw this in diploma exam, and then like when you work with function notation, make sure you put a and k on the outside of the function. So when you put an a outside, you bracket the whole thing, all right? And then if you need to move up, then you put a k there. So don't say the 3 is your k. The plus 3, it could be a k if you're working with x squared. Then you plus 3, then your graph move up by 3. But that's not your starting point. Your starting point is already x squared plus 3. It's already the graph being moved up by 3. So now if you're going to apply any vertical expansion to that, you apply to the whole thing, not just ax squared without a bracket and then plus 3. Then you're ignoring the plus 3. You need to a bracket the whole thing. So therefore, the a's here distributed. All right, like it is distributed. So not just putting an a in front and ignoring the 3 distributed. You have to be showing but plus 24 here. Otherwise, it will be wrong. Okay, it says negative 3, 12 is on the original graph. How are we going to find out the value? Okay, let's do it this way. Negative 3, 12, that's my starting point. All right. When b is negative 2, b is negative 2, well, does it affect x or y? Well, b is horizontal change, so it's only affect x. So after b, the vertical component won't change. You stay at 12, all right? However, it will be reflected, so you times negative 1, and then the effect will be compressed because the number you're going to stretch is 1/2. So you multiply it by negative 1/2. So negative 3 by negative 1/2 become positive 3 over 2. So after you compress it, this is where this point will be mapped to. Finally, you expand it by a factor of 8. So does it change x or y? This is a vertical change. So x do not change. And then you stretch it by 8. So you stretch 0.12 by 8, become 96. You times 8. So that's your answer. Okay, so this is how you work on this question. Okay, next. Multiple choice. Given, this is your question. See, like again, the trick here is, hey, your f of x is x cubed plus 5, right? I'm not saying f of x plus k is equal to x cubed plus 5. I'm not saying that. If that's the case, I can match the f of x with this and then the k, oh, k is 5. So I'm not saying that. So when you look at this, don't say this is your k, all right? This is only k if you are comparing with x cubed. Well, then you have working with another function. But right now, this is my starting point, okay? So I'm not giving you this. I'm not giving you a plus k. So f of x, the whole thing is your f of x. There's no k here. Compare the following. Well, compare this one to this one. So therefore, this 5 is already there. So you're not moving 5 units up. All right. The only change from here to there is x become x minus 1. All right. X become x minus 1. Right. X become x minus 1. This is a replacement notation. If you work with function notation, is f of x now become f of x minus 1, right? Remember replacement, right? X replaced by x minus 1. So now match your standard form, x minus h. So therefore, your h value is positive 1. Minus is part of the form. Positive 1 means moving 1 unit to the right. Okay? Next one. Hey, I don't even see the function. The answer is not 8 unit, right? I don't even see x cubed plus 5. Where is it? Well, rewrite it. Rewrite it this way. X cubed. Rewrite plus a as plus 5 and plus 3, right? That is plus 8. Well, why do I write plus 5? Because now, hey, this match. Match what? Match my function. This whole thing now turned into a function, f of x. So this expression basically is saying what's f of x plus 3 on the outside. Once it's in function notation form, I think everyone know the answer. K is 3, so it's moving 3 unit up. Okay, so change everything back to the function notation format. Read ABHK, then you can answer your question. Okay, let's try the following. All right, this is A. All right, this is B. Well, B has two parts, the negative and 2. Okay, let's do this separately. First, A, expand it by 3. Okay, so I'm going to expand this graph by 3 vertically, all right? Well, how many points do I need to make this graph? I need this point, I need this point, I need this point, like the maximum minimum point and then like the turning point. So I need 5 points to make this graph. I think first stretch it by 5. Stretch it. When you stretch any graph, think of a graph that is made of many points. Stretch the coordinates. Okay, a is a vertical change, so x don't change. You only read the y value. Y value is 0, so you stay at 0. All right. Here, y value is -2, become -6 because you times it by 3. Here, 0 remains 0. Here, 2 becomes 6. Here, 2 becomes 6. Do you see it's only a vertical stretch? So the point that do not change is called invariant point. So the point at 0 is an invariant point. Here we go. Okay, so these 2 points are the invariant point. Other points as graph is being stretched vertically by 3. This is the result. Next, the negative mean you flip it around. So let's flip the whole thing around this way. All right. So if I flip the whole thing around, it's like this. Do you see the mirror image? That's my flipping. All right. This is when A is 3. This is when B is -1. Well, how about the 2? Negative, like when B is 2. When B is 2, you compress it by 1/2. Like you stretch it by 1/2, which means compression. Okay. Horizontally, vertically do not change. So it's same tallest, right? It will be the same height. So you only look at the coordinate. This coordinate is -4, so now it become -2. So let me delete that. -2 become -4 become -2, -2 become -1. Okay. The new graph compresses like this. Like it was 4, now become 2, right? This point is 2, now become 1. So it will be like that. So when I compress it horizontally by half, this is the final result. Okay, do you see how it goes? Okay, so hope it's helped. Finally, the last question. Ooh, okay. How can a graph from the thin change to thick? Okay, well, it was 4. Well, look at the height, right? It was 4, but now it's down to 2. So it has been horizontally compressed by half. It was +5. Right, look at the x component. +5 now become -5. So B is -1. So basically that's your answer, right? Half and -1 here. And I won't answer this question. Like here is, don't ignore it for now. Okay. Okay, that's it. So that's the summary. So hope you learned something from me. Here, good luck. Bye-bye.